So, good evening, students. My name is Aman Kumar, and I am your physics teacher. And today I am going to start a very interesting chapter, which is related to all of us. That is from light, from optics, from ray optics. And in this chapter, the weightage of questions that many questions come from mirror. Okay, in not about plain mirror we are I am discussing about today we will discuss about spherical mirrors. Okay, the most of the part where the questions comes in competitive exams like IIT JEE and different boards exams, but that is spherical mirrors. And as far as I know from my teaching experience, that many of students having confusions in these chapters regarding concave mirror, convex mirror, what formula we can use, or what kind of mirror is this, and this kind of confusion is among all of the students. So I am here to clear all your confusions right now. Okay, so today we will start a very interesting topic, that is spherical mirror, and we will discuss a small introductory part of this mirror, and later on we will discuss the problems and numericals of this chapter. Okay, so let's start. Okay, so we are starting spherical mirror. Spherical mirror. Okay, means what is a spherical mirror? Means reflection at curved surface. Reflection at curved surface. So first we will discuss about what is reflection. As we all know, the most of the incident light reflects back the bouncing back of light. So any highly polished surface such as mirror is known as reflection. So we have studied reflection in plane surfaces, that is plane mirror. Now it's time to study the reflection at curved surface. Okay. So in curved mirror, that is reflection spherical mirrors. So there are two types of spherical mirrors. Okay. First, we will discuss about the spherical mirror. Suppose we have a hollow sphere. Okay, we have a hollow sphere. Let's see in the diagram. Okay, so suppose this is a hollow sphere. Okay, this is a hollow sphere. So if we cut from here sphere, this is a hollow sphere. Okay, so if we cut the sphere from here like this, if we cut the sphere from here, what we will get? What we will get? So we will get 178. Okay, so we will get things like this. 178. So we will get a thing like this. Are you getting my point? We will get a thing like this. This part is this. This part is this. We will get a thing like this. Okay. So if we silver its back portion, means this portion. If we silver is this portion, this portion is silver. Okay. And this inner portion is the inner side is polished side, highly polished side, like mirror. Okay, polished. So it will become a spherical mirror. Okay, the rays coming from here will reflect back something here, here to here, or something else. So if it will behave as a spherical mirror. We have no in plane mirror what? This is plane mirror, this is it's a silver side, this is polished side. So any rays coming will reflect like this. Okay, but in case of spherical mirror, there are some rules to follow. There are something different from plane mirror. So like we have seen in amusement park, have you ever seen in amusement parks that there are different types of mirrors. If we stand in front of one mirror, we will see a tall image of myself. I am looking very tall in some part of the mirror. We can see that we are looking very fat. We are looking very tiny or very low height, this kind of things we have seen in amusement park. So this all are the very interesting phenomena, very magic of spherical mirrors. We can see that these are the scientific magic, physics magic of spherical mirrors. Okay, so if we cut the part of this, okay, if we cut apart, this will look like this. Okay, so if this surface is silvered and this surface is this, it will behave as a concave mirror. Okay, so rays coming from this, okay, we are I am using different color, and if the inner surface is silvered and outer surface is polished and rays coming from like this and going like this, so it will behave as a convex mirror. We will explain this. We will explain the two different parts. Okay, this is convex mirror. So many of the students have confusions. What is concave? What is convex? Some of the students, majority of the students have confusion in this. So let me clear this confusion. Okay, let me clear. So there are two types of mirrors generally. There are two types of mirrors generally. Okay. This is concave mirror. Concave mirror will look like this. This is our concave mirror. Okay. And convex mirror will look like this. This is our, this side is silvered. This is our convex mirror. So we can say that if this part is polished, then this will become, if rays fall on this portion in the upper portion or outer portion, then this will become concave convex mirror, and if rays fall on the inner portion, then this will become a concave mirror. Okay, so remember from the term that is concave, that is from cave. Okay, that term is from cave. Okay, so this side is looks like a cave. Lights are entering, rays of light, beam of light are entering into a cave. It looks like it is pretending like that. So we can remember these terms as concave mirror, means this is a concave mirror. Okay, this is a concave mirror. So clear here, no issues. So now let me discuss the other things, the other properties and nomenclatures of this mirror. Okay. So let me start with the example of concave mirror. Okay, so what is this? This is a concave mirror. Okay, this is a concave mirror. Okay, so let me take an example of a concave mirror. So this is a concave mirror. Okay, so make this as a mirror. Okay, so as I have told you that this is a section, this is a cutting section from a hollow sphere. Okay, from a hollow sphere. So this is the sphere. From it seems like, once a minute, it seems like it is a part of this sphere which I am making from dotted line. Okay, this hollow sphere, this is a part of this hollow sphere, and this portion is cut down. Okay, this portion is cut down, and this is a part of this sphere or this circle. Okay, so if this is a sphere, if this is the part of a sphere, like this is a sphere, so there must be a center. So there must be a center. Okay, there must be a center, and that center C is known as center of curvature. Okay, so if it has a center, Obviously, it is a sphere, so it will have a radius. Okay, it will have a radius. Okay, it will have a radius r. So these are will known as radius. Radius of what? Radius of this curvature. This is a curvature. Okay, this is a curvature. This is a curvature. This will be this is known as radius of curvature. Okay, no issues. And this line from center, this line, this if we join this line from center, okay. So this is an axis on which the center lies and a sphere is settled down. So it is an axis. So this axis, which passes from this is the horizontal axis which passes through the center of the sphere or center of the spherical mirror or concave mirror or convex mirror, is known as, we can write down it as PA. So this PA is known as principal axis. Understood? So this line, this center line is known as principal axis. And this is mirror. This is our mirror. Okay. Only this portion is our mirror. Okay, got my point? This portion is our mirror. Okay. So only this portion is our mirror. Okay. So the midpoint of the mirror, this is the midpoint. Okay. So this is the midpoint. The midpoint of the mirror, we can denote it as P. The midpoint of the mirror is known as pole P. The midpoint of the mirror is known as pole. Okay. And the center point of the pole, this is the pole and this is center curvature. The center point of the pole or the midpoint of the radius. Okay, the center point for between center curvature and pole. So this is the radius and the center point, the midpoint is known as focus F. So F is known as, so we will define focus in a very interesting way when we will discuss the ray diagrams of this mirror, the classical definition of focus. But till now, remember that the focus is the midpoint of the radius of curvature, or we can also say that if this is 10 centimeter, then these two distances are same, that is midpoint. Okay, means radius is equal to, we can say that 2f. Okay, radius will be equal to 2f. If this is 10 centimeter, then radius will be 20 centimeter. Okay, this is the midpoint. The midpoint of these C and P is known as focus. Okay, and this distance from focus to pole, this distance, remember one thing in this chapter, in the chapter of mirror or lenses, everything, optics, every distance we will measure from pole. Remember one thing, every distance we will measure from pole, not from anywhere. Okay, every distance will be measured from pole. Remember, every distance will be measured. So this length is known as F. So this is known as focal length. This length is known as focal length. The length of a mirror from pole to focus is known as focal length. Okay, so understood here? Any issues? So these are the basic terms of a mirror. One more thing that is known as aperture. So this distance, okay, I am highlighting from a different color, this distance. One end of the mirror, this is the other end of the mirror. The distance between two ends means the distance of open mouth, how much the mirror is open, or how the distance curvature between this end and this end. Okay, these two ends, the distance between these two ends is known as a aperture. Okay. So distance between two ends of the mirror is known as aperture, means how the mouth of the mirror is, how much it is open, wide, or what is the curvature. Okay. So this is the main terminology of a mirror. Same concept applies on convex mirror. No issues. Okay. All things are same. Okay, so now we will discuss about some basic concept, the rules for making image. So how an image will be formed in this mirror. Okay, we know the making of image, formation of image from plane mirror. Till now we have no, but now we will discuss how the images are formed using these spherical mirrors. Let us start from concave mirror or convex mirror. Okay, both rules for making image. So we will start from rule number 1. Let us take a concave mirror. So I think this is my concave mirror. Listen very carefully. These 2-3 rules are very important in case of this chapter. Okay, this is my principal axis. This is my center of curvature. This is my focus, and this is my pole. Okay, these 2-3 terms. This is my principal axis. The center line is my principal axis. So what first rule says? First rule says if a ray of light passing parallel to principal axis, this is my principal axis. If any ray passes parallel to principal axis and after striking the concave mirror, it will pass through the focus. After reflection, when the ray strikes on the concave mirror, after reflection, it will pass through the focus like this. See here. If a ray is passing parallel to principal, suppose this ray passes parallel to principal axis, this is going. So after reflection, when it strikes on mirror, it will reflect back, it will pass through, it is compulsory, it is mandatory that it will definitely pass through the focus. It have to pass through from focus. Okay, so it have to pass through from focus. It will go like this. It will, sorry. So it will go like this. The ray will go like this. The ray, if a ray is coming parallel to the principal axis, will pass through the focus after reflection. Rule 1. Now go to the rule number 2. Again, we are making a concave mirror. These laws are same for both convex and don't confuse, don't mix up. These laws are same for both. Okay. So this is my principal axis, this is my center of curvature, this is my focus, this is my pole. Okay. So now the second rule says if a ray passes through focus, so what happens if a ray passes through focus? Okay. The second line says if a ray passes through focus. So this ray is passing through focus. Okay. So after reflection, it will become parallel to principal axis. The vice versa of first rule. Okay. So after reflection, it will pass from like this. After reflection, it will pass from parallel to principal axis. Means we can conclude both the rules and we can say that if a ray passes through if a ray is parallel to principal axis, it will pass through focus, and if a ray will pass through focus, then it will become parallel to principal axis. Okay, no confusions. Okay, now what happens? The third rule about, we will discuss about the third rule. Okay, let's see. Third rule. Now we are again making a concave mirror. Okay, this time I am in hurry. I am making in a very speed. Okay, so this is my center of curvature. This is my focus. This is the pole of the mirror. So what happens if a ray passes through the center of curvature? Suppose if a ray passes through, we have known the all circumstances of focus. Okay. So if a ray passes through center of curvature, then what happen? What will happen? So if a ray passes through center of curvature, once a minute, I have to make a very clear diagram. Let me make a very clear diagram. If a ray passes through center of curvature, then it will bounce back in its original path. It will bounce back. So it will again pass through, after reflection, it will pass through center of curvature. If a ray comes from center of curvature, it will go back to center of curvature. This is the case of a plane mirror. Like what happens like in plane mirror? In plane mirror, if a ray strikes perpendicular, it will go in the same path. Okay. So it will behave like this. Now, the fourth rule. So till now we have discussed parallel, focus, and center of shape. One more point is left, the pole. Okay, what happens if a ray directly strikes to the pole? Understood my point? What happens if a ray directly strikes to the pole? Let's see. So I am making a concave mirror again. This is my center curvature, this is my focus, this is my pole. So if a ray passes through pole or strikes to the pole like this, so it will go like this, making this will become the case of a plane mirror, making angle of incidence I equal to angle of incidence R. I is equal to angle of incidence R. These things we have studied in plane mirror. This will become the case of plane mirror. That means if this ray strikes at 30 degree from principal axis, so this will go back in 30 degrees from principal. This will make an angle 30 degrees. So reflected incident ray will be 30 degree from principal axis, then reflected ray will make an angle 30 degree from principal axis like this. So these are the four general rules to make a image. So their image are two types. Let me explain the types of image. So one is real and other one is virtual image. So let me say what is real image. So many of the students are confused on what is real image, what is a virtual image. So in some books, what are the terms are written like real image, this are real image, and that are image. So let me explain in very neat, definite, and clear way what is real and what is virtual image. See, so what is real image? So if after reflection rays meet, so what we need to make an image, to formation of image, for formation of image, where image is formed. Okay, the image is formed at the intersection point of rays. Okay, where the rays meet, at that point image is formed. After reflection, where the rays meet, at that point image is formed. So we need, for intersection we need minimum 2 rays at least. Okay, we can have 1,000 of rays, lakhs of rays, but minimum 2 rays we need for to make an intersection. Okay, so see, like an example. Okay, I am taking an example here. Let's see in a new slide. Okay, so I am taking an example of here, like this is our mirror, this is our concave mirror, this is pole. Okay, this is our center curvature, this is focus. Let me take an example of mirror. So when rays meet in real after reflection, when rays, suppose one ray has become one ray came parallel to the mirror, passes through focus, okay, and one ray passes through the center of curvature and got bounced back in this direction, in the same direction. Okay, so this is the intersection point. So image will be formed here. So what happens in this case, the rays meet in real after reflection. They met in real. So in this case, real image is formed. Real image means the rays after reflection meeting in real. They are meeting really. They are meeting in real. So the real image is formed. Okay, understood my point? When rays after reflection meet in real, it forms real image. Okay, real image is formed. Now take a case of in a virtual image. What is virtual image? When rays generally don't meet in real, but we will make them to meet forcefully. Okay, artificially, forcefully. If we forcefully meet them, or we forcefully make them to meet, then in that case it will become virtual. See how? Once you will see the diagram, these things will be clear. So this is again a concave mirror. This is my principal axis. This is my center curvature. This is my focus. This is my pole. So suppose a ray suppose an object is here, a ray is coming parallel, passes to like focus, okay, and again a ray passes from center curvature. So it will pass like this ray is like this, and like this will pass like this, and this will pass like this. Okay, this will pass like this, and this rays, what happens in that case, these two rays become divergent. So as far as for concept concerned, parallel rays do meet on infinity, but divergent rays never meet. Divergent rays never meet. What can I do? We can extend these rays. We can make them meet artificially or forcefully. We can make them. Suppose we will extend these two rays like dot here. This will also dot here. So this will meet at that point. So image will be formed at this is the intersection point of these two rays. The image will be formed here. This image will be virtual. Now, see in this case, what happens in this case? The rays after reflection didn't meet in real. They didn't meet in real. Okay. What we tried to make them meet. Okay. We met them. They didn't meet in real. One ray is after reflection is going like this, one ray is like this. Both the rays are divergent. But behind the mirror, we have extended the rays. And we make them meet artificially or virtually. It is not a virtually meeting. Okay, virtual meeting, not in real life. We are teaching in virtual manner. You are not in front of me. Okay, I am not in front of you. But it's a virtual manner, but with the help of technology, with the help of internet, with the help of things, we made this possible to make the connection. Okay. So in this case, with the help of different things, we make them meet behind the mirror, or they are meeting not in real, but we made them meet by extending the rays back. So in this case, the image will be virtual image. So from now till now, your point is clear. We have discussed the introductory part of spherical mirror. What is concave? You have clear concave mirror. What is concave mirror? Or how images are formed? These things. So in next class, okay, in my next lecture, we will discuss the different phenomena or different cases of mirrors. So spherical mirrors, like concave and convex mirror. So when object is placed at this point, image will be formed at this point. What will be the size and nature of image? It will be virtual, it will be real, it will be magnified or diminished, it will be upright, it will be erect, or it will be inverted. So we will discuss all these kinds of cases in a single class, okay, and next class. So thank you for today. We will discuss these things later on. Thank you so much.